Okay, class, good afternoon. So this is another topic in power plant engineering. So this is the first presentation of this topic. So machine foundation. Okay. So we have here some definitions of uh, terms in foundation. Okay, engineering. Okay. So foundation. This is part of structure rather, which transmit the loads to the supporting materials. Okay. Another we have here, monolithic foundation. So it's a concrete foundation which is formed by pouring the entire concrete mixture continuously at one time and allowing the structure to harden as a whole unit. Okay. Another is grouting. So a process of filling a small clearance between machine and foundation. So after the machine is aligned and level by using a special hardening mixture. So this is the mixture that is inserted in between the bed plate of the machine and the base of the foundation. Okay. So what are the functions of the foundation, class? Okay. So one, of course, this supports the weight of the engine. Another is maintain proper alignment with the driven machinery and of course absorb the vibration produced by unbalanced forces created by the reciprocating or revolving masses. Okay. Another class, so this is very important. So how you are going to estimate the materials needed in order to produce a foundation. Okay. So we have here the foundation should be concrete of, okay, 1 part cement, 2 parts sand, and 4 parts broken stone or gravel. So preferably 50 millimeter maximum. Okay, so that is class D proportion. 1:2:4. Okay, so we have here some proportions. Okay, so in order to produce 1 cubic yard of concrete using 1:2:4, it requires 6 sacks of cement. Okay, 0.44 cubic yard of sand, and of course 0.88 cubic yard of zone. Okay, and in SI we have here also, in order to produce 1 cubic meter of concrete using the same proportion, it requires 7.8 sacks of cement, 0.44 cubic meter of sand, and 0.88 cubic meter stone. So it is very easy to determine the number of cement required, number of sand, and the number of stones. If you know already the volume of the foundation and then multiply it, of course, by the number of cement. So for example, in cubic meter, so that is 7.8. And then another is the sand and stone. So you can easily determine how much or how many sacks of cement, sand, and stone. Okay? So for a given properties of concrete, we have here in determining the volume. Okay. So Bx represents the volume of the materials required. Is equals to the density of that material, and then multiply the volume of concrete, and then multiply it by the ratio. So whether it is 2 or 4. Divided by the specific gravity of the materials and the density of water. Okay. So this is how you are going to determine the volume maybe of the sand or the stone or gravel. Okay. So recommended dimensions. Okay. The distance of the edges of the foundation from the bed plate must be 6 inches or 150 millimeter to 12 inches or 300 millimeter to secure the bolts within the foundation. So this is class in designing the size of the foundations from the bed plate of the machine it requires 6 inches or 150 millimeter to 12 inches or 300 millimeter on both sides of the foundations. Okay? So another, the vertical distance from the floor or soil level to the top edge of the foundation must be around 6 inches. Okay? 6 inches, class. Okay? The foundation depth may be taken to be 3.2 to 4.2 times the engine stroke. So if you know already the engine stroke and then multiply it by 3.2 or 4.2, that is now the depth of the foundation. Okay? So the lower factor or well-balanced multi-cylinder engines, the higher factor got engines with fewer cylinders or on less firm soil. Okay? So we have here the simple illustration of the foundation, class. Okay? So take note that the foundation is a trapezoidal form or in a form of a trapezoid. Okay? Wherein we have here the upper base A and the lower base B. Okay? And we have here with W sub M represents the weight of the machine, and W sub F, of course, weight of the foundation, and of course the H is the height of the foundation. Okay? So, foundation should be isolated from floor slabs or building footings at least 25 millimeters. So, do not forget to put a clearance from the slab or maybe from the wall of at least 25 millimeter. Okay, in order to prevent vibration or the transmission of the vibration. Okay, so weight of the foundation, we have here the empirical formula wherein W sub F is equals to E. So this is the empirical coefficient. W sub E or the weight of the engine multiplied by the square root of N, where N of course is the number of revolution. Okay, so take note, class, that E is found in phase ME code, so which is 2008, and then page 13. Okay, so take note that if the value of E is not given, so from the table, so use 0.11 or 0.11. Okay, so we have here, class, the values of E. So take note that at the right portion we have here for single acting vertical, so for single cylinder that is 0.15, vertical again single acting 2 cylinder 0.14, and then single acting vertical 3 cylinder 0.12, and then single acting vertical 4 cylinder, 6 cylinder or 8 cylinder that is 0.11, and then single acting horizontal, so single cylinder 0.25, and so on and so forth. Okay, so just look at what is the arrangement of the cylinder and then look for E. Okay, so foundation mass should be from 3 to 5 times the weight of the machinery. So this is the assumption, class, that you are going to do, to use. Okay, 3 to 5 times the weight of the machine. Okay, so take note that the machine, so it has a nameplate wherein sometimes it states what is the weight of the machine. Okay, another is in computation 2,406 kilogram per cubic meter or 1,000 or 150 rather pound per cubic foot may be used as weight of concrete. So take note of this, class. Okay, 2,406 kilogram per cubic meter. So that is the density that you are going to use for the concrete. Okay, another, we have here the volume of concrete foundation. So if the weight and speed of the engine are not known, the volume of concrete for the foundation may be estimated by the following data from PSME Code 2008 page 13. Okay? Volume of concrete foundation. Okay? So we have here for number of cylinders. Okay? 1, 2, 3, 4, 5 to 8. Okay? High speed engine 0.15 to 0.095, 0.076, and then 0.065 and 0.057. Take note, class, that the unit of this is in cubic meter per kilowatt. Okay? So, just multiply this by the number of kilowatts of the engine, and then you will automatically determine what is the volume of the foundation required. Okay? So, another we have here the bearing pressure. So, this is class very important. Okay? The first objective is to achieve by making its supporting area sufficiently large. The safe loads vary from 4,890 kilogram per square meter for alluvial soil or wet clay to 12,225 kilogram per square meter. Okay? The weight of the machine plus the weight of the foundation should be distributed over a sufficient soil area which is large enough to cause a bearing stress within the safe bearing capacity of the soil with a factor of safety of 5. Okay? So, here is now the formula. So, knowing the bearing capacity of the soil, solve for the base width for the machine foundation. Use only 1/2 of the given safe soil bearing capacity. If you already the value of the soil bearing capacity, just divide it by 2. So, that is now the safest bearing capacity that you will use. Okay? So, that is equal, of course, to the weight of the engine plus weight of the foundation divided by the area of the base of the foundation. Okay? So, or simply, W sub E plus W sub F over base multiplied by the length of the foundation class. Okay? So, this is very simple equation. Okay? So, then compute the depth of the foundation or the height. So, that is volume of the foundation is equals to A plus B, or the length of the upper and lower base divided by 2 to determine the average. Multiply it by the height of the foundation multiplied by the length. Okay? So, make adjustment in the dimension if necessary, provided that the required volume is maintained and without reducing the base area. Okay? Do not reduce the area of the base of the foundation class. So, of course, to sustain the weight. Okay? So, do not reduce. Okay? So, another, we have here the steel bar reinforcement. Okay? So, of course, it requires steel bars in order to prevent cracks. Okay? So, concrete foundation should have steel bar reinforcements placed both vertically and horizontally to avoid thermal cracking. Okay? Weight of reinforcing steel should be from, okay, 0.5% to 1% of the weight of the foundation. Okay? So, if you know, class, the weight of the foundation, and then multiply it by 0.05 or 0.005. Okay? So, or 0.01. Okay? In order to determine the weight of steel bars. Okay? So, foundation bolts. Okay? Foundation bolts of a specific size should be used and surrounded by a pipe sleeve with an inside diameter of at least 3 times the diameter of the anchor bolt, and the length of at least 18 times the diameter of the bolt. Okay? No foundation bolt shall be less than 12 millimeter. Take note of that, class. Do not use a bolt or anchor bolt with a diameter less than 12 millimeter. Okay? Another is to prevent pulling out of the bolts when the nuts are tightened. The length embedded in concrete should be equal to at least 30 times the bolt diameter. Okay? The upper ends are surrounded by 50 mm or 75 mm metal sheet or metal pipe, 460 mm to 610 mm long, to permit them to bend slightly to fit the holes to the bed plate. Okay? Thank you very much, class. That ends my presentation.